Hello everyone, welcome to my YouTube channel. So guys, in the previous video, we have take a look at what is adjusted R-square. Before that, we also look at what is R-square or the coefficient of determination. So we have came to the point that adjusted R-square is always less than or equal to R-square, right? So in this video, we are going to prove that it is obviously true using this formula, right? So before getting started to prove it, if you guys haven't watched this R-squared and adjusted R-squared videos, please go there and take a full idea of what is R-squared and what is adjusted R-squared, so that will be helpful for your life for the machine learning field works, right? And in this video, I'm going to just prove that this is true always for sure using this formula, right? So guys, I hope that you all watched the previous R-squared and adjusted R-squared videos. So let me quickly start to prove that adjusted R-squared is always less than or equal to R-squared for sure, right? So yeah, we get started. First, I write this equation because from this equation only we are going to prove that, right? So if I write this equation, okay, yeah, let me choose a color pen. Okay, right? So let me write the formula. Adjusted R squared. For the sake of easiness, I put ADJ only, but it's adjusted R squared, guys. So that's basically going to equal to this equation, right? So if I write this 1 minus 1 minus R squared. So using this equation, we can't directly say that adjusted R squared less than or equals to R squared. So we need to make, or we need to reduce this equation. We need to adjust this right hand side so that we can say that R squared is greater than or equal to adjusted R squared, right? So we just adjust this equation for our purpose, right? So what I'm going to do is to basically I'm going to take this n minus p minus 1, right, to the both. So it will make this 1 to also n minus p minus 1. And at the same time, with this minus, I'm going to, right, multiply or this elaborate these terms, right? So 1 multiplied by n minus 1, that will make n minus 1, and minus r squared multiplied by, sorry about my terrible drawing, I'll try to keep improve my drawing skill or writing skill. Yeah, so this will be the next so yeah, it seemed to be that n minus 1 can be cancelled and we can make it more easy, right? More easier term. So that I'm going to multiply this term by minus 1 and I'm going to subtract it. So you can see here plus 10, and if I multiply this minus 1 by n, that will make minus 10. So n and minus 1 will be cancelled. Like that, here minus 1 and here plus 1, so it will be also cancelled. So what will remain after this work will be this minus p, and this minus multiplied by this minus, and it will make minus into minus plus r squared n minus 1. So yeah, you can see that we have adjusted more easier manner, right? Here it's more completing in 2 terms, and here also multiplication. But you can observe Here there's n minus p minus 1 and here n minus 1. What if it makes n minus p minus 1? That will make it only r squared term. So that way we can compare the adjusted r squared and r squared. So for that, what I'm going to do is to basically I'm going to add minus p here, right? Only add minus p. But we can't stop by adding minus p because we can add additionally minus p. So we have to add plus p, not plus p with plus p r square, because inside this r square we add minus p, that means minus r squared p. So for that we have to cancel it out by adding plus p r square. Don't worry guys, we'll get rid of these terms. So this will be our next term for sure, right? So from this I can cancel these terms, so that will make r square. And here what I can do is here also p and p, so I'm going to take minus p. So minus p is going to be a factor, so minus p into 1, that is minus p. Okay, and here minus because it's plus, so I need to put r square. Now n minus p minus 1, right? That's it guys, that's it. I'm not going to take into the next step because it seemed to be that next term would be factorizing this 1 minus r squared into 1 minus r into 1 plus r. No, because here the r squared term is there, we can't make it 1 minus r into 1 plus r, right? Because that r squared is a single term, single, like an a, you can say 1 minus a, right? So that's a coefficient of determination, so we can do like that. So that's a single term, right? So we can make it that, so we can't go for another step. So this step is enough. This step is enough for us to find the relation between adjusted r squared and r squared. Here, if we want to compare this adjusted r squared and r squared, we have a single r squared here, right? Additionally, we have this term. So if we zoom into this term, right? If we zoom into this term, we can see here, here's a minus, right? Here's a minus. And if you see this term, capital N is the sample size and P is the number of independent variables. So generally capital N is greater than, very greater than P, because N will be in nearly thousands, so in millions, but P will be maximum of 50 or 100, that kind of only, right? So generally this term will be positive. This term is positive. And I told that in the last video that r squared is generally between what range? Tell me guys. R squared is basically between 0 to 1, right? We have seen this in the last video. Sorry. In the previous of the last video, right? So if we take this and subtract r squared in both sides, what we'll get? 0 less than or equals to 1 minus r squared. So guys, you can see that 1 minus r squared is also positive, right? So it is also positive. So a positive term divided by a positive term is also going to be a positive. And P is also going to be the positive. So that means this whole term is going to be positive, right? For sure it's positive. So a positive term is going to be subtracted with r squared. That's what this adjusted R square. So from that, what you can say? We are going to subtract a positive term with the R squared and we are getting the adjusted R square. That means, that means adjusted R square is less than or equal to R square. Voila, we have proven that. You can wonder that, okay, less than I absurd because we are subtracting a positive term. Why the hell is this equal sign is also coming? Yes, the equal sign should come because I could say that R square can be 1, or you can see here 1 minus R square less than or equal to 0. So if it's positive, that means if it's only the R minus R square is greater than 0, then it will be here less than sign only come. But when it's 1 minus R square is going to be 0, this term will be 0. That means this whole term will be 0. And that point, this adjusted R square will be equals to R square. So generally what we can say is, so let me write it here. So adjusted R square always less than R square, always, right? And adjusted R square equals to R square when R square is equals to 1, right? Sorry, here I made a mistake. Less than or equals to, right? So we have proven that adjusted R square is always less than or equal to R square, and adjusted R square will be equal to R square when R square is equals to 1. That means adjusted R square and R square and yeah, adjusted R square and R square will be equals to 1. So guys, in this video, we have solved that, or we have proven that adjusted R square is always less than or equal to R square, right? For sure. So hope you guys could enjoy this mathematical proof, I could say. So if you really like this video and if you really think this video has a good potential contents, please like this video, subscribe my YouTube channel and press the bell icon and also share with your friends, guys. And see you soon in another video. So until that, keep learning and be safe also, guys. So okay guys, see you in next video. Bye.